what's the meaning of ready?
So for the warm up today, we've already gone through it, let's put the answer up. You have two different tops, so for your region, so you have to do two different integrals. So one from -3 to 2 with this top and the linear bottom, and then one from 2 to 7 with the radical top and the linear bottom. Add them together and you get your total area. Moving on. So today we're doing trig substitution again. So this is section 8.4 part B. Today you will learn how to reformat integrals by completing the square. Evaluate definite integrals using trig substitution, which will involve learning how to change limits. And review other integral trig applications using trig substitution. So here we go. Oh, those are all my questions. So, which I will add to. I'll add to those once I take a look at what you guys have written. Someone earlier in one of my other classes was asking, had forgotten the power reduction formulas. You don't have to write this down, but if you've forgotten the power reduction formulas, I just showed her how they were created. And so, but anyway, those are them. They'll be on the slides if you need to write them down again. Okay. And then someone else during third asked for a better explanation of how to change limits on a definite integral. So I wrote out this example just for her, but I'm going to just show this to you just so that you are exposed to how the process works and it's not such a hit you in the face when we get into the harder problems. So here's what happens. If you have a definite integral from 0 to 1, these values are x values. There are actually some people when they write their integrals who actually identify the variable with the limits. So you don't have to, but they do, just to help keep track. So if these are x variables, well, you have to do a u substitution on this problem. You don't have to, but we, just for sake, we're doing it. So we did a u substitution. So when you replace your variable in the argument of your integral, the limits have to match the variable. If you were to rewrite x limits with a variable of u, you'd basically be lying, right? You'd have something that isn't true because this would not equal that because the variables don't match and you can't plug them in. So you have to change your variables. How do you do it? Well, if x is 0, you just plug in a 0 for x and say, oh, well then u would be 0 plus 4. So now u is 4. If x is 1, u equals 1 plus 4. So now u is 5. Once you do that and you take the antiderivative, you don't have to convert back to x's. Because as long as your limits are in terms of the same variable as your function, you can just plug them in and be done. Right? So
That's a wow.
Is that a wow?
Yeah, that's a wow.
Oh, okay, well good. Wow. So, yeah. So, but it is something that you have to learn how to do, and it is on the AP exam. Not just in the free response, but there are multiple choice questions where they'll say, they'll give you this integral, and then they'll say, hey, this integral equals this, what would the new limits be? And they'll put little, like an a equals and a b equals, and then they'll have a equals, b equals, so you have to pick which ones they are. And it's just testing to see if you know how to change the limits, right? So you have to be able to do it. And we'll get into this more when we get into our examples today. But before we start changing limits, we need to learn how to complete the square, which we already know. But I want you guys to try this. So take a minute. First thing I want you to do is rewrite this integral, completing the square on the quadratic that's in the radical. Once you complete the square, are there any questions on how to go from here to here? Did everyone do okay with their square completing? We're all good? if you need help, you can just call me over, raise your hand. Once you get to here, I want you to go ahead and sketch your triangle and write out start doing your trig substitution. I know you can do this problem using a regular U sub, but we're learning trig sub, so we're gonna do this with trig. They just see you, yeah.
And I was confused, because like sometimes most people do what you said, but then sometimes they do the triangle.
See, to me, if you could do either, I always go with U sub, but, you know, I don't know, it's their call. Yeah. Good start. Got it. The first time I was ever observed by a principal, I fell down.
Nice. Oh, good thing you weren't a gym teacher, right?
I did, I tripped on a backpack and fell right on my face. Yep.
Yeah, okay.
Don't know what to do? Okay. So, oh, that's right, because you were out yesterday, so let me teach you. All right, so beautiful, completing the square. So we draw a triangle and call an angle theta, and then you're just looking at this stuff in the radical. And if it's something and minus something, the first term is your hypotenuse. If it's something plus something, then both terms are both sides. So I'm just gonna write it here. So
Then I unluckily get called out.
there.
Yeah, I know.
Maybe a couple of things.
It was in like I said, okay, if this is not saying I'm just not.
So if you have the square root,
I wouldn't allow it.
square
Oh, Brian,
root,
say it.
square, you're gonna put.
The camera's not running
You're
yet.
gonna put- What? Oh, don't do that to me. All right. You put x here, you put a here, and then by Pythagorean theorem, the
Did you
side
have
is the
dx
square
secant
root
theta,
of x
d
squared minus a.
Alright, d
Is
theta.
that what
D
it
theta,
says?
there you go.
If you have a square root of x squared
Okay, what'd you get for
plus
dx?
a squared, then you put
I got 2 secant tan, 2 secant theta, tan theta.
these on these two sides, and this becomes
Yeah.
this third side.
Care about
Okay? And then the only other one is if you have a squared minus x squared, then the a goes, you know what, I'll go ahead and put it here.
What did I
Might as well
get for
just
the
have all
answer?
three.
Yeah.
Wait, how would you do this plus 3?
Okay, hey guys.
It should be minus three.
So now the
No,
a
it's
goes
plus
to the
three.
hypotenuse,
No,
x
I
goes
did.
here, and then this
If you had an
is
x minus 3 over
a
here.
squared
How
minus
about
x
you,
squared.
You can leave the x minus
So,
3.
this one, x squared minus a squared, so
Oh, you
this
did.
goes three.
Oh, the d theta.
You put the number on the bottom.
I changed the dx.
Life is easier if
Oh,
a
the
goes
dx
here.
is.
Guys, put the number on the bottom, it makes your life, it's still, you'll get it right either
Oh,
way,
whoa,
but
wait.
it keeps you from dealing with negative integrals. It keeps you from having to deal with cosecants and cotangents.
I don't know how long this got off for, but it was not pointing at the screen.
Oh, good. All right.
Cole Dunbar fixing this.
Oh, thank you. Thank you so much.
Are
All
you-
right.
Are you sure you fixed the cold?
I'm, yeah. Get over here.
You okay?
Yeah, hold on.
Okay. All right.
Like that, Brian?
Yeah, man.
All right, the whole point of sketching the triangle is so that you can write these in terms of trig functions. So the first thing I always do is I start with my
Oh, dude,
root.
this is.
So you have
You already.
x minus 3 squared minus 4.
Did you get 2
Alright.
secant squared theta
How do I
plus
relate
3
this to
secant theta, and you take the
Always
integral
pick
back?
this in the number
And
and
then-
say, oh,
so you
well,
get,
let's see, tan theta
you
equals
get,
this over 2. So
2 tangent
equals
theta plus 3ln
Alright,
secant theta
now I look
plus
at my x
tangent theta.
X minus 3,
Well,
let's see.
yeah, so the final answer
Secant
is
theta
2.
is x minus 3 over 2,
Or
always
the
get the
final
number
answer
on
is
the bottom.
root
So then
Okay.
x minus 3 would equal
So then the
2.
tangent.
x minus 3
Secant
squared minus 4
And then I need a
plus
dx.
3
So I'm gonna
ln
first
Then you
solve
just
that.
have
value
that, then you just factor out the two
secant
secant
theta
plus.
plus
x
3
minus 3
And now I
divided by
differentiate.
2
No, no, you mean factor
plus
in?
is
It's already factored out for me.
secant tan.
x minus 3
Oh, well,
squared
no, I mean, you
minus
cancel
Now,
the
I'm
shares,
Yeah.
cancel
I
the
just start
tangents,
substituting.
then you just factor
Is 2
this.
secant
Boys,
theta
that was
plus
wild.
3.
But then you can take that like one half
Oh,
out.
You know what I'm saying?
Secant
So you
times-
do like that? So you get 2
This
secant
whole
squared.
root,
So this is where it'll look.
Dude,
the whole
Yeah,
bar is
plus
equal to
3
2
secant.
theta.
Yeah.
And then dx is 2 secant theta tangent theta.
Okay, somehow I got an answer of
Secant
5.
theta tan theta d. And now you're just simplifying and doing everything you can do. So you're gonna have to just, you cancel a tan and distribute it. But yeah, that's the basics, and it just takes practice kind of on the triangles and stuff.
Okay.
Alright, so let's talk about this one. So, hopefully you all got that the root was equal to 2 tan theta. You had to solve for x, right? X minus 3 was 2 secant theta, so x is 2 secant theta plus 3. Did you guys all figure that out? And then you still find your dx, right? So you end up with this integral. X is 2 secant theta plus 3. Dx is 2 secant tangent theta, and then the whole root is equal to 2 tan theta.
how's it going, Trace?
From there, it's just a lot of algebra, right? You could have deleted the tangents right away. I went ahead and distributed first and then canceled the tangents. So you distribute, I canceled a 2 and I canceled a tangent from every term, and you're left with this. And of course, the antiderivative of 2 secant squared is 2 tan. And the antiderivative of 3 secant is 3 natural log secant plus tangent. Can you leave your answer like that?
No.
No, you gotta convert back to x's, right? So you look at your triangle and you say, what is the tangent of theta? Well, tangent of theta is this root over 2, right? Then you need the secant of theta. The secant of theta would be x minus 3 over 2. So you just plug those in, and you get this lovely thing. And then, of course, if this is a multiple choice problem, that natural log of a half would get absorbed into the constant, right?
Yeah.
So there you go.
The other one's still right though. So.
Good.
Yeah, but
How's that feel? Is that all right? Good.
But if it was a free response, then that would be beautiful.
why would that?
I'm not gonna walk, I'm not gonna have you guys do this one, you can put this down if you want. Someone, this is gonna come in handy on your quiz today. So, how do you complete the square when you have a negative leading coefficient, right? So the way that I do it is I factor a negative out of my first 2 terms, my x squared and my 2x. The 3, just push it off to the side. It's not part of the square that you complete anyway. So you complete the square. Normally to balance, since you're adding 1, you'd have to subtract 1, but you have to be careful because everything in here is being multiplied by this negative. So you're actually already subtracting 1, so you have to add 1 to balance it, right? And then when you're done, then you combine your constant and then minus whatever that is squared, right? So that's how you complete the square if you have a negative leading coefficient. And I will put this back up if you want while we're taking the quiz today, if it's something you need to practice. Okay, let's talk about converting some limits. So here we go. First thing you need, remember trig substitution only applies when you have a root of a quadratic, right? Anytime you have a root of a quadratic, you're good for trig substitution. How can we write this so that we have a root of a quadratic? Yes, Gisha?
Yeah, you could take a squared out of it, like at the bottom,
Uh-huh.
and then separate the 2, and then you would have a root 1 minus x squared times 1 minus x squared squared.
Oh, okay, that would be one way to do it, and that actually would work just fine, right? The way that I did it is I just kept the root and just wrote it to the fifth. But you can try your way too, and I bet it would work fine, right? So however you want to approach it. What I want you guys to do is take a minute, do your triangle, get your trig functions all kind of set up, and go ahead and do your replacement integral without any limits. Take a minute and do that, and then I will talk to you about how to convert the limits.
Mrs. Price, when you make a triangle, did you figure out which side would be?
No.
Okay, when you make the triangle, if it's a something minus something, right, either x squared minus constant or constant minus x squared, well, for this one, the constant has to go on which side? The hypotenuse, right? For the other sides, it actually makes no difference. You'll get a positive either way. So you can put, if you want to put the x on the side or the x on the bottom, it doesn't matter. I will tell you, I think I put the x on the side, I did. But it doesn't make it any harder or easier with whichever one you do. The only thing that I know is helpful is if you end up where you have a constant on one of the sides, it'll make it easier if the constant goes to the bottom. Right? But everything else, you get the same level of difficulty no matter how you make them. It's okay. Nothing wrong with
What'd you say? Before you came.
How do you like these spines? Yeah? Now, does this do indefinite intervals?
So,
Oh, do you guys
so it'd be just like.
It's not on it. So basically, this can be like what an 80 number is.
Yeah, it was more easy.
Really?
Whole conversation.
Sorry,
Invisible, yeah. The new 84.
What sign?
The old ones.
Don't mark.
Okay. All right.
Cool. So for this, you just plug that 0 and 3 or 2.
89 can do indefinite
So
intervals,
sine 0 would
and
be
when it displays, it shows
0.
them the way
Sine
yours
0,
does,
or
but when you
sine
type
0
it
would be
in,
0.
you don't get the little blanks, you have to type it all straight.
Oh, yeah.
Is it
Yeah,
like
and then the sign.
root 3 or 2?
Yeah.
They'll always say that. So it's like, it's just easier.
It doesn't have to.
It just says where they're.
Oh, because 89 was.
No, I didn't. Well, that's why it's not allowed to be ACT.
You only know the arc sine too.
We'll go.
Okay. All right, guys, let's just check up on where you're at. So, write down, please. So this is what I've got for my trig functions. Yours might be slightly different depending on where you put the root and the x, right? So yours could be switched. That's okay.
Arc sine.
So here's the thing now. To convert the limits, what happens is, if these are x values, right? So if x is 0, that means 0 equals sine theta, right? So theta is really the arc sine of 0. You have to ask yourself, what angle has a sine of 0? 0, right? So if x is 0, theta is 0, and it doesn't even change. It's just 0 to 0. Root 3 over 2. If x is root 3 over 2, that means root 3 over 2 is the sine of theta. So what angle has a sine of root 3 over 2?
Pi over 3.
Pi 36. Pi thirds, good. So if root 3 over 2 equals sine theta, that means theta has to be 1.
Yeah.
right?
I'm gonna mess
So
up the
now
numbers.
your new limits
Oh.
are gonna be 0 to pi thirds when you fill
Especially 'cause
in
now we're like giving them more
your,
trig.
oops, your trig functions.
It's nice.
A little bit nice.
You can do cosine and cos theta. Just like,
No.
cosine to the fourth theta. Yeah.
Now, what's fun
But
with
that's
this
secant.
Or cosine.
is, when you end up with secant to the fourth, how do we do an integral of secant to the fourth?
Oh God, not these again. Times tangent squared.
Beautiful. We take two of those secants and convert them to tangents, right? Or, no, this is a no calculator problem. Yeah.
So we just.
So go ahead and do that. Take a minute, use an identity, convert two of the secants to tangents, do some distributing, see what happens. Yes?
You should have people write on the walls so that when we're taking
Yes.
tests, we can look at them and get some answers.
Yeah.
Because Mr. Thomas.
Yeah, we draw like a unit circle.
No, because in the room there's like a unit circle
He
and like
has
the trig
special
identity.
permission, I think, to let his students write on the
Well,
walls,
you should
but
just
I
draw
don't
one
have
on the board.
that permission.
Well, you should try to get that permission.
You should get a unit
Yeah.
circle on the board.
Because there are like there are literally answers in his room.
Yeah.
So
Like test it.
yeah.
The unit circle is useful.
No, but if I don't know like the unit circle, then I just look up there.
Or like that one right there.
I used to sit right
a unit circle right there.
I used to sit right under Megan's.
See, the problem is I don't want you to get so that you are dependent on something that you won't have on the exam.
Yeah. But I'm already dependent on it, so it's just.
You can put like unit circle up.
Can't we just take the AP exam in Mr. Thomas's room?
Oh, that's right.
That'd be sick. Just transfer his room to the gym.
Okay, so if you get to this point, did you all get here?
Yeah.
This is where I need to teach my former students a little trick, all right? This is where the whole guts thing comes in. So my students, we would have let u equal tan, so du is secant squared theta d theta, and so you would have had the integral of u squared du, which is 1/3 u cubed, right? And then you would have had to plug the tangent back in, or change your limits and you could just plug them in for u and be done. But here's the gist of it, and Thomas students, tell me if I speak this incorrectly. You're looking for a function and its derivative. And if you clearly and simply have a function and its derivative, if the function is just a simple function raised to a power, right? And you have its derivative there, the function like tangent, is the tangent the guts? Right? We call
Yeah.
tangent is the
Yep.
guts of the power function, right?
Yeah.
Okay,
Yep.
and then if you have the derivative of the guts, right? Okay, yes, okay. So if you have guts to a power d guts, all right? Then you just apply power rule on the guts. So if this is tan and I've got the derivative of tangent, then I just apply power rule to tangent squared and get 1/3 tangent cubed. And I don't have to do any u sub, which is pretty nice, right?
A little bit
Yeah.
nice.
So there we go. So my students,
You want to read?
we all.
It's like doing a U sub in your head.
It's like, it really is. It's basically just doing the u sub in your head. Yeah.
So we can do those things like that in our head. Why don't it still work for like you subs?
You go the other way
don't.
too.
You don't?
You do like a
I mean,
secant.
Thomas still made us write out u and d and like
Yeah, you
us
could,
tests
'cause you
and
could
stuff,
do-
so we have to write out like
secant
u,
tan theta.
so we write here, u equals tan of theta.
You did?
Yeah, so we just write out u equals
No,
tan
you
of
do,
theta.
like, if you use the U method, you can make your U.
You did?
secant, or,
Oh.
We didn't have to, but that's what he encouraged us.
secant, and then you
Oh,
use
okay,
secant.
alright. So you are encouraged to still write out the u and the du, but you don't have to actually write the integral in terms.
Joey,
Is that right?
No, wait,
Okay.
so we would write out on the left side.
It's like doing half of it in your.
No, but you have secant tangent.
Yeah.
Oh, yeah.
Yeah.
No,
Alright,
secant
so
squared
then you have to plug in the
plus
pi
secant
thirds and the
squared
zero,
squared.
and,
How is that
Just-
equal
That
to
only
tan
works if you have
theta?
one
I get the tan theta part, but I get the 1/3
so
tan
now you're just
to the
evaluating
third
the definite integral.
theta.
Wipe it up.
Okay, let's do another one.
So maybe you tan.
Okay, a torus.
Oh, I got you. So you just have to
I like
So,
donuts.
write down please. So a torus is basically just a circle that has been revolved about an axis. So you end up with the shape of a donut, right? It's funny, because the first image in my mind was not a donut. When I thought of revolving a circle around an axis, one of the teachers has a paperclip holder that's a circle. I don't know if anyone's ever seen a paperclip holder.
Oh.
Anyway, but that's exact shape, and that's the first thing that hit my head when I thought of torus. But anyway, it's basically the shape of a donut. So, for you, just so you know, and pretend that that's not there for a second. I'm gonna Alright, if we have this equation, this is the equation of a circle. What is the center of the circle?
What is in the center of the circle?
5,
Not what
0.
is at the center.
5,
What
0.
is the
5,
center?
0.
5, 0.
5, 0.
5, 0, right?
Way to go,
Think
baby.
x minus h squared plus y minus k squared equals r squared, right? hk is your center. So 5, 0, what's the radius?
2.
2. So if we draw the torus, or the circle that is the base of the torus, we have a circle that's centered at 5, 0 with a radius of 2. Now, since we're revolving this about the y-axis, we want to find the volume. Which method would be the most efficient one to use? Did you guys hear that? You all agree?
Say it louder for the camera.
Loud and proud.
Shell method. Why shell?
Use X.
Because it's a vertical axis, right? So you can stay with dx.
X.
Alright, I took the liberty of going ahead and solving the equation for y in terms of x. And I want you to notice, so the top half is the positive root 4 minus the quantity x minus 5 squared, and the bottom half is the negative root 4 minus the quantity x minus 5 squared. And we're going to revolve this about the y-axis. How could we make our lives a little bit easier? Yes?
If you just did the shell method on like the top half and then doubled it.
That's exactly right. That's exactly right. So that's what I did. I just did shell method. Okay, they changed, the screens changed for a second. There's my equation. So I just did shell method on just the top half and doubled it. But I'm gonna cover this up again for a second.
Whoa.
Just to see if you remember, I don't like yellow though. There we go. Just to see if you remember how to set up shell. Take a minute and see if you can remember how to set up a volume by shell.
Yeah, it's 2 pi. 2 pi, 3 to 7. So it'd be 4 pi, right?
Yeah, yeah, technically. And then the height is just x.
Height is just y, right?
Well,
So it's root
yeah, the height is
4.
y.
So it's root 4 minus x minus 5 squared.
Since we're revolving about the y-axis, what is the radius?
Times
And
3
then the radius is just
x.
No, the radius is 2.
no.
Radius is
Not
2?
of the circle of
The height
shell.
is 2 x equals.
Not the radius of the circle, the radius for your volume
So
of
the radius is
pyramid.
x,
Yeah,
right? Yeah, so it's just
X,
x
yes,
times root
yes.
4
Yes.
Okay,
minus 5.
good. And then the height.
Times 4 pi.
It's root 4 minus x minus 5 squared.
Exactly. It's just your y, right? So it's the square root of 4 minus the quantity x minus 5 squared. What has to go in front of every shell method?
2 pi.
2 pi. Very good.
Wait, although, for this one, shouldn't it be the same pi because we're multiplying it by 2?
You are exactly
Way to
correct.
go, Ryan.
Hey.
Brandon, Harvard, 2021.
So your
that was
limits,
Brian did, by the way.
would your limits be x values or y values? X values. So what are your limits going to be?
3 to 7.
3 to 7. Very good. And you can just think of those intuitively by doing the radius on the center. But you could also find them by setting y equal to 0 and solving for x, right? Getting those x intercepts. All right, good. So let's check our setup. All right. So any questions on the setup? Okay. All right. So hey, look at this. It's a perfect candidate for trig substitution, right? So. Okay.
More calculator.
No. Just in chat.
So I want you guys to sketch your triangle, label the sides, apply your trig functions, rewrite the integral,
I really like
change the limits.
Dude,
Wow,
say I'm
it's awesome,
popping.
it uses everything
Then.
you learned.
You think I can top this from right here?
No, this is a
If I
real
crumble it up.
problem, man, no calculator.
Why should I not use this when it's already in my hand?
And when it's up to test. Exactly. Oh, dude, I should get rid of
Yeah, this is a no calculator question.
Right, and then what we're doing is times 2 to double it so that we get the whole volume.
So this one is it, it's like around already, but that's just like one part of it. Yes, sir. So it's just like cut.
This is like a cross section, yeah. So like if you took a donut, right? Sliced it down in half and then just looked at one of the sides, that's what you would see. Like if you picture it, we rotate this all the way around.
Sorry.
But anyway, you rotate it all the way around. You're getting this, but you're getting this donut kind of a thing. It's, this circle is spinning around the axis.
Okay.
Yes. I'm sorry, I just messed up your doodle. All right.
What?
Okay.
Yeah.
Okay. How you doing, Evan? Let's see. Perfect. Okay, so now what you want to do is write like this root equals, and then so you can write it in terms of a trig function. So, and always use the number as one of the sides. Yes. Perfect. And then do the same thing with your x.
It's not too bad.
Oh, sure. Okay, so, so since we're in thetas now, so you have x equals 2 right? So this
Yeah, so you got 2 cosine theta plus 1 theta. You got 1.
Hey, did you get pi for the first?
For the 3? Like,
Yeah.
yeah, pi.
And then what'd you
And
get?
7 would be, it would be just 0.
Zero.
Yeah, pi to 0.
No, it'd be 0 to pi. And then
It's 3 to
negative.
7.
No, and then because you can't go that way on an integral.
Oh, yeah, true. So 0 to pi and then
then you pull out
negative
a
pi.
an equation that relates x and theta, right?
But you get another negative inside anyway.
Because you can't go from pi to 0.
Yeah, and then you pull out a negative. But then there's a negative
But then you gotta flip it. What?
It's arc sine though, right?
Yeah, okay, so like if you plug in 3 into that thing, you get
Yeah, you
pi.
get 3 minus 5 over 2.
So negative 2 equals 2 cosine theta.
Negative 2 over 2, so negative 1.
One.
So arc sine negative 1
Is pi.
It's cosine theta is negative 1, so you need theta.
pi 3 pi over 2.
So it's the arc.
No, it's just pi. Where'd you
When
get 3
it's
pi?
pi, though, the cosine is negative 1, sine is 0. Because sine is your height.
You want cosine.
You want arc cosine. It's arc cosine. Yeah, look, we use, look, Joey.
Guys, when you're doing your inverse trig,
Where'd you put your x minus
remember we're
5?
only using principal values when we do our inverse trig. So So if you want the
Yeah,
inverse
no, I drew my
cosine
triangle.
of
So I solved
1, the angle would be 0. If you want the inverse cosine of -1, the angle would be pi. Because cosine principal values always go 0 to pi. Sine and tangent go negative pi halves to pi halves. Answer is always going to be one of those.
Brian, depends on how you draw your triangle.
Now, I did my triangle, a lot of you guys have your triangle different, I have my root on the bottom, so my x's are different. Yeah. So if you have your root on the side, everything's gonna be different, right? It'll all be the opposite function.
right here.
But anyway, it
Oh,
doesn't,
yeah,
you'll
yeah,
end up,
yeah.
we'll all end up with the same answer.
So it's 16.
It's gonna be really fun.
And then 2 sine, 16 times sine squared theta times.
By the way, this one is a great candidate. You either ended up with a sine squared or a cosine squared in your integral. How do we integrate sine or cosine squared? What do we have to do?
Trace.
Power reduction, right?
Pick up the 4 as well.
Multiply it out.
Can you do what?
Pick out a 4.
Take out a 4. Oh, sure, absolutely, you could. I just left them in, but yeah, you can pull them out.
Oh, she did different.
Yeah.
Okay, that makes sense.
Yeah, so just remember, if you have your triangle set up with the x's on the bottom, everything that you have is going to be opposite what I have. Yeah, so it's okay.
Wait,
You
would
should
they,
end up with the same answer though.
would the intervals still be opposite, or would they be different?
Yours, if your x minus 5 was 2 cosine
It would be
theta, then your limits would be
0 to
pi.
pi. Okay, yeah.
But we would have to take a negative out, right?
Because it would be pi to 0, and then you take.
Oh,
you
it's
flip
pi.
it.
Yeah.
Oh, you have to flip.
Yeah.
Yeah,
Yeah.
sorry.
There you go, Trace.
Yep.
Trace somewhere, say. 2021. 2017. It's 2021.
For what?
Trace somewhere, say.
I come right 7.
Trace, come on, go. Class of 2021.
No matter how you do it, you should end
How
up
do you
with the
simplify this
same
now?
final answer.
Good.
Good.
You split it up,
Call me
and
over
this
if you need
turns
some help.
into
Yes.
1/2. 1/2. What was it, 1/2?
Yeah, so you have to multiply by a negative in order to make it 0. Oh, okay, sorry. And then flip that. Yeah.
What was the
Yeah,
one
guys,
before?
if your
What's the
limits
half
went
negative?
pi to 0, you have to put a negative out front and make them go 0 to pi.
Wait, cool. If it's like sine squared, it's 1 minus cosine 2 theta over theta. Or over 2, over 2.
You have oh, I see. Okay, so you did negative 5. 4 out. Okay, okay. So you have 2 cosine squared. That's 5 centimeters.
Alright,
Okay,
cool.
so this is
We
a
can
use of,
attempt.
or you could do like what we were talking about today with
What?
robots, right?
I wanna have a camera.
So your would be sine, your
We're gonna attempt the greatest shot
Do it, Zoro.
of
This
4th hour price.
is like the power.
Hannah, catch this.
Do you remember power reduction? No. Yes, yes, yes. So this would be 1/2 times 1 minus sine 2 theta.
Do it.
So,
Cosine 2 theta,
That's
sorry.
about how
1/2
most
times 1
whiteboard
minus
is.
cosine 2 theta, sorry.
I'm not in swag ball, I can say it.
Over 2.
Okay, I think we're done. Yeah, just actually just throw it in. Alright. Alright, so, yeah, any questions on how to, by the way, when you are doing, oh no, this is all good. I was to say, if you had, there's another problem where we have to do 2 theta, but we don't on this one. Let's just plug in. The first time I did this problem, I freaked out, and it was really today. Because I was running the numbers, and I kept getting, I got a 0, I got all of this, but as I was writing, I was so worried, because I had 0 and a 5 pi and a 0 and a 0 and a 5 pi and a 0, and I was so sure I was going to end up with 0, and then I was going to have to find my mistake and start it all over again, but it worked out. Alright, so anyway. Alright, so this problem you do not have to do, but it is an extra fun, really challenging problem, right? So if over the weekend you're sitting around and you're like, I want to do a really challenging trig substitution problem, right?
That sounds
Then you can give this one a try. I will tell you this, just in case it ever appears again, and I'm not hinting, I truly don't know, but if it ever does appear, when I first started this problem, it's just area, when I first started it, I started as a dx, and so I was doing top minus bottom, the square root minus the h, but to find the points of intersection, right, you end up getting points where each is the square root of a squared minus h squared, you have plus or minus. And the problem is when you convert to trig and have to convert your limits, you end up with like the arc sine of the square root of a squared minus h squared. It gets really messy. And so I scrapped it and decided, hey, if I did dy, then my limits are just h to a. Bam, right? So I converted it to a dy and did a right minus left kind of a thing, and I didn't even do the left half. I just did the right half and doubled it. So if you're curious on how this pans out, the solution is there. I will tell you, it's not a pretty solution, right? I thought it would, the only reason I started the problem was I thought that they made it up so that it would be like this really cute, cool solution that's simplified, right? And it really doesn't. It just ends up like that, right? So there you go. But that's there if you want some extra practice. Yeah. Okay, so we no longer have 3 cases for trig substitution, so this is moot. Okay. However, the main thing to know is, are you able to apply trig substitution if you needed to for some reason? Okay? Alright, good. So it's time now to take our first quiz. And let me turn off the camera.
No, you said if you had it, if you've done it once, you don't have to do it again. You don't have to change it back to 0.